Number 1 was the equation of a tangent line. To write the equation of a line, we need a point and a slope. I gave you the point, we need the slope. My suggestion, anytime you are doing derivatives, anything you can do at the beginning to clean it up would help. Instead of writing 5 over x squared, how could we write that? Minus 2 over x cubed would be 2x to the negative 3. So the derivative would be a negative 10x to the negative 3 plus 6x to the negative 4. Is everybody okay to that one? We know our point is negative 1, 7. We need the slope. The slope is from the derivative. This is the same thing as saying negative 10 over x cubed plus 6 over x to the 4th. So if we plug in a negative 1, negative 1 cubed is, so negative 10 divided by negative 1 is 10. Negative 1 to the 4th is a positive, so we get 16. So now we have a point and a slope, so we can write the equation. Y equals mx plus b. So add over the 16. The equation is y equals 16x plus 20. Is that one okay? Number 2. So we are finding the derivative. Again, if we can simplify first, that helps a lot. We have 3x squared over 2x e to the x. If you really wanted to simplify on this, what could you do? Oh, we could cancel an x before we ever do this. So we have 3x over 2 e to the x. So we could do quotient rule from this point. If we wanted, you could also rewrite it with negative exponents. I'm just going to do quotient rule to review that. So quotient rule is low. D high, what's the derivative of 3x? Minus high. D low. 2 is just a coefficient, so it stays. What's the derivative of e to the x? Over low squared. What do you notice at this point? I can take out 2 e to the x from everything. So we get 3 minus 3x over 2 e to the x. Number 3 we were okay with. Number 4. So this is asking for the second derivative. So we have to do the derivative twice. We have 2 options. We can leave it like this. As it's written, what rule would I have to do? Quotient rule. If you don't want to do quotient rule, how could you rewrite it? So the derivative, exponent comes down, inside stays the same, subtract 1 from the power, times, what's the derivative of the inside? 1. So we just get negative 2 x minus 3 to the negative 3. So second derivative, coefficients would stay, so the exponent comes down, so negative 3 times negative 2 is 6. Inside stays the same, subtract 1 from the power. Derivative of the inside is still 1, so that doesn't add anything to it. Sounds okay? Number 5, how would I have to do this one? For quotient rule. So, low D high, what's the derivative of the top? Minus high D low, derivative of the bottom. So we have a 2t plus 10 over low squared. From here, if we multiply, so this one we just take times 1, so it's itself. Here we have to FOIL, so plus 10t and minus 10t cancel. What do we do next? Yeah, we distribute this negative. So t squared and negative 2t squared is just a negative t squared. We have a 10t. 75 plus 50 is 75 over the denominator. Is that okay? Number 6, we have 2 options. If we keep it how it's written, we have to do the quotient rule twice, once for each term, which is fine. We can do that. I guess really we have 3 options. We could rewrite these with negative exponents and do chain rule, so that's the second option. If you really wanted, you could technically even get a common denominator and make one big fraction at the beginning, and then you only have to do the quotient rule once. So, like we've talked about on these, a lot of times there are multiple correct answers. It just kind of depends on your approach. What do you guys want to do here? Negative exponents? So this would be x plus 2 to the negative 1 minus x minus 2 to the negative 1. Please label when you do your derivative. That helps me a lot when I'm looking at your papers to know the difference between when you're just simplifying something and when you actually find your derivative. So then chain rule, exponent comes down, inside stays the same, subtract 1, so it's now a negative 2, times, what's the derivative of the inside? Derivative of x plus 2. Minus, we do the same thing here. Exponent comes down, inside stays the same, subtract 1 from the power, derivative of the inside, derivative of x minus 2 is 1. So we get a negative x plus 2 to the negative 2 plus x minus 2 to the negative 2. Number 7. I'm asking for derivative. You can do it however you want. So our 2 options are, if I do the derivative as it is written, what do we have to do? Product rule. Or, if you don't want to do the product rule, what could you do? multiply and then do the derivative. We'll get the same answer. So which way do you guys want to do it? Product rule or multiply first? So derivative of the first, derivative of x cubed plus 1 is 3x squared times the second. The first times derivative of the second. Derivative of 3x squared is 6x. At this point, it's pretty easy to go ahead and simplify a little bit. We distribute. So then we get 15x to the fourth minus 3x squared plus 6x. Is this helping you guys? Number 8. Let's look at this one. So 3 parts. Problem A. So this derivative, we just have to do the chain rule. Exponent comes down, inside stays the same, subtract 1 from the power times derivative of the inside. Derivative of x squared plus 1. Okay, so you could write that as 10x times x squared plus 1 to the 4th. B, do this one as it's written, and we could do the quotient rule. You could also write it as a negative 5 power and do product rule. So low, d high, what's the derivative of x? Plus high, d low. So the 5 comes down, inside stays the same, subtract 1 from the power, derivative of the inside. Isn't that what we just did right there on part A? All over, don't forget your denominator, low, squared. If it was to the 5th, when you square it, it is now to the 10th. So you will notice we have an x squared plus 1 in every term. So we can cancel the smallest exponent. We have a 5, 4, and 10. So we can take out all 4 of these. That would leave 1 of these and 6 of those. So we have an x squared plus 1. Over here, x times 5 times 2x is 10x squared. Over x squared plus 1 to the 6. I have a mistake, don't I? That's supposed to be a minus right there. Low d high minus high d low. So we get negative 9x squared plus 1 over x squared plus 1 to the 6th. Do you guys know your product, quotient, and chain rules? Make sure if you are struggling with those in any way, shape, or form, you come see me. Plus 1 to the 5th times x to the 5th plus 1 to the 4th. So we have to do the product rule. Derivative of the first. So I'm focusing on this piece. So it's derivative. Exponent comes down, inside stays the same, subtract 1 from the power, times derivative of the inside. Derivative of x to the 4th plus 1. Couple of you, I am noticing when you do product rule and you have chain rule within it, you are forgetting to carry down your second term. It's derivative of the first times the second, we still have this, plus the first times, then we do the derivative of the second one. So the 4 comes down, inside stays the same, subtract 1 from the power, derivative of the inside. So just any easy simplifications we could do. So we would have a 20x cubed, x to the 4th plus 1 to the 4th, x to the 5th plus 1 to the 4th. Here we could take the 4 and the 5x to the 4th, so 20x to the 4th, x to the 4th plus 1 to the 5th, x to the 5th plus 1 cubed. You guys staying with me? Is this helping you or am I wasting time? Okay, number 10. What do we have to do on this one? Product rule. This should be getting pretty repetitive. We're doing the same things over and over again. If it helps you guys, if you are a person that tends to forget terms, you're welcome to have highlighters or something, colored pens, colored pencils. I don't care. If color helps you make sure you're getting both terms, you can do that. So when we do this product rule, derivative of the first, so when I carry that down, we have 2w minus 2. And then don't forget to bring down the second. Plus the first. Derivative of the second. So for that derivative, the 4 comes down. W plus 3 stays. Subtract 1 from the power. Times the derivative of the inside, which is 1. For the sake of time, can I stop there? You guys know the only thing I'd like you to do is 4 times 1 is 4, and bring that 4 to the front of that term. Number 11. How might it be helpful to rewrite that problem? If it's 1 over something, just go ahead and bring it up as a negative exponent. So our derivative, exponent comes down, inside stays the same. Not 36z, 36. Subtract 1 from the power. That's another mistake I see. Negative exponents, sometimes subtracting 1 we have an issue. Negative 11 minus 1 is negative 12. Derivative of the inside would be a negative 7 plus 18 z to the 5th. And you could leave it like that. Number 12. If you want to make your life easier on this one, we have a 3x squared minus the square root of x, so that would be x to the 1/2, plus 7 over the square root of x would be 7x to the negative 1/2. And now it's just a product, or a power rule. So exponent comes down, so that's a 6x, subtract 1 and it's 1, minus 1/2 comes down, x. When you do 1/2 minus 1, 1 is like 2 over 2. So 1 over 2 minus 2 over 2 is negative 1 over 2. This one, the negative comes down, so negative 7/2 x. Negative 1/2 minus 1, so minus 2 over 2 is negative 3 over 2. Number 14. Okay, different ways of writing this. At the very least, instead of a square root, we should do a 1/2 power. So exponent comes down. Inside stays the same. Subtract 1 from the power. 1/2 minus 1. Times derivative of the inside. So we have to do quotient rule. Low d high minus high d low over low squared. Right, this one is kind of nasty. We could, depending on what kind of simplifying we wanted to do, we could break that up and give each one the exponent. In this, we should go ahead and multiply out that numerator. So that gives me a 2t cubed plus 2t. If I distribute the negative and the 2t, minus 2t cubed plus 2t. What happens there? So we have a 4t over t squared plus 1 squared. All right. Simplifying. 1/2 times 4t, 2t. If you put these together, when you're multiplying, you add exponents. So that's t squared plus 1. Negative 1/2 plus 2 is a positive 3/2. And then we still have this one. I think on my answer, I went ahead and brought it to the bottom because the negative exponent goes down to the bottom. If you left it on the top with a negative 1/2, I would not have counted that wrong. So that would have also been okay. But that's how I got the answer I gave. Just take your time on the simplifying. Don't try to rush through it. Show your work, and you should be okay. Let's talk about 16. Cosine squared x means you have cosine of x squared. Sine cubed x means you have sine of x cubed. So when I go to do this, what am I going to have to do? Chain rule. And product rule. So derivative of the first one. Exponent comes down. Inside stays the same. Subtract 1 from the power, so it's now the first. Times derivative of the inside. Derivative of cosine. All of that is just the derivative of the first. So product rule is derivative of the first times the second. So I still have this one. Plus the first one times derivative of the second one. So the exponent comes down. Inside stays the same. Subtract 1. Derivative of the inside. Derivative of sine is cosine. Make sure you review those derivatives of trig functions. So if we multiply, we have a negative 2 cosine times sine cubed. It's just cosine sine to the 4th. Here we have a 3. Cosine squared times cosine is cosine cubed, and a sine squared. Number 18. Let's focus on these trig functions for a little bit. So we have cosecant (1 over t cubed). That's t to the -3. Remember, can you have a trig function without an argument? No. So this is not a product rule. This is cosecant of that thing. So we start on the outside. Derivative of the outside. Derivative of cosecant is what? So it's derivative of the outside. Inside stays the same. Times derivative of the inside. So what's the derivative of t to the -3? So you get a positive 3 to the -4 cosecant to the -3 or tangent to the -3. Know the derivatives of those trig functions. I tried to put all of them on here. We've had quite a few so far. Number 19. We have secant of 3t over tangent of 5t. So we have to do quotient rule. Low. D high. This is one thing because the secant of 3t. So what is the derivative of secant? Inside stays the same. And then we have to do derivative of the inside. What's the derivative of 3t? 3. So there's low d high minus high d low. So what is the derivative of tangent? Inside stays the same, times, then you do the derivative of the inside, which is 5. All over low squared. Really not much you could do outside of pulling the coefficients to the front. So for the sake of time, I'm not going to do that here. Number 20. Okay, is this a product or chain? This is secant of that whole thing. So it's a chain rule. You start on the outside. Derivative of the outside. Derivative of secant is secant tangent. The inside stays the same. That's the derivative of the outside, inside stays the same, times. Now we work our way in, derivative of the inside. So derivative of cosine, negative sine, inside stays the same. Derivative of the inside is 3. So again, really the only thing you could do at this point is pull that -3 to the front. T1. So our function so we start on the outside. Derivative of the outside. All of that inside stuff stays the same. times, then we work our way in, derivative of the inside, so that would be an f prime, the inside stuff stays the same, times, working our way in, derivative of the inside. Okay, and then it told us that x was what? 1. So if we change all those to 1s. So f of 1 is 2. So then we have to do f of 2, which is 3. And f of 3. Oh, f prime of 3, yeah. F prime of 3 is 6. Alright, this one we have f prime of f of 1, which is 2, and f prime of 2 is 5. The last one, f prime of 1, we were given as 4. (22) If you have position, how do you get velocity? First derivative. And then second derivative is acceleration. So this is cosine of 2 pi t. So our velocity, we do the derivative. Derivative of cosine is negative sine. Inside stays the same. Times derivative of the inside. What's the derivative of 2 pi t? 2 pi. So we just have a negative 2 pi sine 2 pi t.
So what is pi?
Just a number. 3.14. Just a value. Just like any other coefficient. So acceleration, second derivative, we know the coefficient just stays. So that negative 2 pi isn't going anywhere. What's the derivative of sine? Cosine. Inside stays the same. Times derivative of the inside. What's the derivative of 2 pi t? 2 pi. Alright, and it told us that it was 5 seconds. So negative 2 pi times negative 2 pi is negative 4 pi squared. If I put in 5, that's a cosine of 10 pi. So think every time you go around the circle, there's 2, 4, 6, 8, 10. It's just like cosine of 0, which is so that's where we got the 1. 23, we didn't ask about it, but this will be a multiple choice question on your test. Make sure you know that a derivative is a rate. So it's not telling me what the cost is, it's telling me how the cost is changing. Okay. 24, when I ask you to draw a derivative, what do you have to remember? High and low points. Oh, I did a horrible job of drawing that. But your high and low points are where it hits 0. Then it was increasing, so the derivative was positive. Decreasing, so derivative was negative. Increasing, so positive. Decreasing, negative. So is that okay? The last one. This is going to be the last question on your test tomorrow. Using the definition of derivative. Because remember, this is going back to the very last bit of chapter 2. So the definition of derivative. Do you guys remember what that is? Limit h approaches 0, f of x plus h minus f of x all over h. Alright, so things you guys really need to look at before tomorrow. Make sure you know the derivatives of all your trig functions. Make sure you know product and quotient chain rules. And look over this definition of derivative. So, if we do that, we have the limit h approaches 0, f of x plus h. So that means we go to the equation, we replace that x with x plus h. minus f of x all over h. What we did usually here was get a common denominator. We took this one times 3 plus 2x on top and bottom. This one by 3 plus 2x plus 2h on top and bottom. Can I go ahead and write these as one big fraction, since we're getting the common denominator? So this would be the first one minus the second one. Okay, this was all over h, so we rewrote that as 1 over times 1 over h. Remember, we have to do this if I say definition. Now, you could certainly go out to the side and do chain rule or quotient rule or something and check yourself, but you have to have this work. So if we distribute the negative, then these cancel. So we have a negative 8h then my h's cancel. So you can plug in your h equals 0. So we get 3 plus 2x times 3 plus 2x on the bottom. And I'm sorry guys, I know I kind of flew through today and I'm sorry that I wasn't here Friday. I am happy to go over more stuff with you. We have an NHS meeting in advisory, but it'll be short, so if anybody wants to come in during advisory and stick around, or if you want to come in before or after school, tomorrow, first hour, they're working on a project, so if you're needing extra help or practice or want to go over something, you can